In a groundbreaking study, physicists claim that wormhole may already been detected. Not only that, but we also imaged them. Wormholes are hypothetical objects in the universe that connect two distinct regions of space-time. They may even connect 2 points in two different universes. Physicists have made significant progress in understanding the nature of these exotic structures in the past few decades. Recently, a team of researchers used Google quantum computer to show that wormhole of general relativity and entanglement of quantum mechanism are essentially the same. And now a team of scientists has claimed that these potential hypothetical spacetime structures may have already been detected. In fact, the two supermassive black holes we image so far cloud be wormholes distinguished. But how is that even possible? If a black hole are indeed a wormhole in distinguished, how can we differentiate between two? Finally, and most importantly, why is the understanding of wormhole essential to develop the theory of everything? To answer these questions, it is important to go 100 years in time. Wormhole were first theories of Ludwig Flamen in 1916. While reviewing the solution to Einstein field's equation gave the Karl Schwarzschild later in 1935. Albert Einstein and Newton Nathan Rosen used the theory of general relativity to expand on this idea. They proposed the possibility of bridges through the space-time that could connect two distinct points in the universe, no matter the distance between them. They were named Einstein-Rosen or Einstein bridge, but Einstein was not happy about these hypothetical bridge because the equations show they were not transversible. So he thought, what's the such a short in space-time if there no one can use them? In the same year, Einstein and Rosen write paper with another physicist, Boris Podolsky. The Einstein-Rosen-Podolsky of EPRF paper, quantum entanglement, which Einstein referred to as a spooky action at a distance. At the time, there was no reason to believe that these two papers were linked. In other words, no one could have been ever thought that ER equal to EPR. About 20 years ago, quantum gravity researchers John Maldacena mathematically show a peripheral black hole in a particular type of space is connected by a wormhole. And then in 2013 he realized that wormholes are an outcome of quantum entanglement. That is, ER is equal to EPR. So if two black holes are connected via wormholes, they are quantum entangled and vice versa. It is equivalent to saying quantum theory and gravity interconnected. This duality is generally idea behind the holographic principle. This duality is generally idea behind holographic principle, which mathematically relate gravitational aspect of quantum physics, and that is a picture of quantum gravity and the role of wormhole in it. But the most critical question is how we discover these wormholes. Unfortunately, the detection of wormhole become a problem because wormholes are hypothesized look like black hole. Therefore, it is hard to distinguish between wormhole and black hole. Nevertheless, team of scientists from Sophia University of Bangalore suggest a method to find the difference between black hole and wormhole. They study certain parameters that may be unique for each of them. So far, scientists have only looked at similarities between two exotic objects, but this team found out how they differ from each other. Firstly, they study the polarization property of radiation emitted by a assertion disk around the black hole. They are compared this with affected regions of space where wormholes might existed, analyzed at the polarized property. The comparison led the creation of a simplified model of a wormhole through. This model could tell matter encircling the entrance of a wormhole behave different from that falling into a black hole. It shows the particle enclaring the wormhole opening and polarized by threshold magnetic field of the wormhole. The interesting thing is that kind of polarization mission were detected recently during the capture of the first image of black hole at the heart of M87 galaxy and the Milky Way. So if the model proposed by the team accurate, there is a high possibility that M87 star is itself a wormhole. We will tell the rest in part 2 video.